Today we're going to continue our discussion about sampling distributions, but we're going to get a little bit more specific. We're going to talk about the sampling distribution of the sample proportion, or the sampling distribution of p hat. And to begin my illustration to begin with, I have this Rossmann-Chance applet. Okay, if you're interested in looking at this applet, you can find it at this web address. And what it is we're going to sample Reese's Pieces. So I have a population of Reese's Pieces here. I don't know how many are in there, but I do know that half of them are orange because of this right here. Okay, I said in class the other day that some statisticians like to use pi instead of p for their proportions. This applet does that. However, we are always going to use p, so let's just imagine that this is a p instead of a pi. So what's going to happen when I take one sample is it draws a sample from my machine of Reese's Pieces, and then it calculates p hat, which is the proportion of orange imminent Reese's Pieces. Okay, our p hat here is 0.48, and it graphs this p hat value on this distribution. So then let's take 9 more samples. Okay, this is my population still. This is the very last sample that it drew, and these are my 9 p hat values, or 10 p hat values, that have been calculated from each of my samples. Notice that currently I don't really know enough about it to talk about its shape, but I can say that the mean is 0.528 and the standard deviation is 0.1114. So if I go ahead and let's take 390 more samples so that my total number of samples goes up to 400. Okay, again I have my population distribution, I have my distribution of my sample, and then I have the sampling distribution of p hat, which is all of the values p hat has taken for each of those 400 samples. Notice that I'm getting very, very close to the mean of my sampling distribution. It's getting very, very close to my population proportion. Okay, that is because p hat is an unbiased estimator. Very, very close. And my standard deviation is below 1/10. So this is a very good standard deviation and a very good mean. Okay, notice that this first question in our notes says to explain the difference between the distribution of the population, distribution of the sample, and the sampling distribution. The distribution of the population is all of my M&Ms, the proportion of orange, blue, brown, and yellow Reese's Pieces inside my candy machine. The distribution of a sample is the amount of each color in one sample, and then the sampling distribution is all of the values that p hat has taken, which is the proportion of orange Reese's Pieces in the sample, for all of my samples. So how would this change if I increased my sample size to 50? So let's reset that. Let's take 400. Notice that I'm still relatively symmetric. I am still unimodal. However, my mean is 0.502 and my standard deviation has decreased even more. So, again, the larger the sample size, the less your variability is, and the less your bias is for a sampling distribution. Okay, what if I change this to 0.15? Let's reset this and draw these samples. Okay. Notice that still I am unimodal, relatively symmetric. My mean 0.154, it's very close to the population proportion, and my standard deviation is still very small. What if I change this back to a smaller value, but leave this at 0.15? So if I reset this, and then draw the sample, notice that now my sampling distribution is not quite symmetric. It is instead a little skewed to the right. Okay? we can take that information back to our notes and say that it is okay to say that the distribution of p hat is approximately normal. And when we talk about it being approximately normal, we talk about it being roughly symmetric, and unimodal. And it's okay to say that the distribution of p hat is approximately normal as long as we can say that n, which is our sample size, times p, which is our proportion, is greater than or equal to 10, and, not or, but and, n, our sample size, times 1 minus p, is also greater than or equal to 10. This is called the normal condition. And if you will notice, our distributions of p hat were normal until we got to the point where n was 20 and p was 0.15. And if you multiply 20 times 0.15, you actually end up with 3, which is less than or equal to 10, which is why our distribution looked slightly skewed. Okay, if we continue and we talk about the mean and the standard deviation of the sampling distribution of a sample proportion, there are some things that we can learn from other sampling distributions. For example, the mean of a sampling distribution of p hat is always equal to the population proportion, always equal to p. So if I know what p is, then that automatically tells me what my mean of my sampling distribution of p hat is. And this is because p hat is an unbiased estimator. I can determine the standard deviation of p hat by using this formula. P times 1 minus p divided by n, and then take the square root. Okay, this one, however, has a condition. I can only do this if my 10% condition applies. Okay, the same independence condition as from last chapter. N, sample size, little n, has to be less than 10% of my population size. That's the same independence condition from the last chapter. And we call it the 10% condition. Okay, these formulas are on the AP formula sheet, so you will have access to them during any test, including the AP test. Okay, now that we have this basic information about sampling proportions, or sampling distributions for the sample proportion, tongue twister, out of the way, let's look at how we can use the fact that we can assume that it's approximately normal to help us work some problems. So if we look at some problems like this one, the superintendent of a large school district wants to know what proportion of middle school students in her district are planning to attend a 4-year college or university. Suppose that 80% of all middle school students in her district are planning to attend a 4-year college or university. Okay, right here, they are giving us P. We are assuming that the population proportion is equal to 0.8 because the population would be all middle school students in her district. And so if 80% of those are planning to attend a 4-year college, that is P, which is also the mean of our sampling distribution. Okay, our question is, what is the probability that a simple random sample of size 125 will give the result within 7 percentage points of the true value? Okay, here's something else they're giving us. They're telling us n. Okay, so since this is a word problem, we want to do our 4-step process. Okay, state what is the probability. that the percentage of middle school students who plan to attend a 4-year college or university is between, and we said 7 percentage points. So that would be 7 below it, which would be 0.73, 73%, and 7 above it, which would be 87%. Okay, then we need to plan. I already know that the mean of the sampling distribution is 0.8. Okay, I don't have an actual population size, but because it says it's large, we can assume that NP, which is N is 125 and P is 0.8, is greater than or equal to, well, that's the normal condition. I need to be doing the 10% condition. Oops. We can assume that 10 times 125 is greater than the population. So greater than the number of students. Okay, doing this 10% condition enables me to find my standard deviation. So I can say that the standard deviation of p hat is equal to the square root of 0.8 times 0.2, which would be 1 minus p, over 125. And what I actually end up with for my standard deviation is 0.036. Okay, then I need to check my normal condition. I need to say that since 125 times 0.8 is equal to 100, which is greater than or equal to 10, and that 125 times 0.2 is equal to 25, which is greater than or equal to 10, we consider the distribution of p hat to be approximately normal. Okay, so that means that my distribution of p hat is normal with a mean of 0.8 and a standard deviation of 0.036. So I am looking in the do part for the probability that p hat is between 0.73, because I'm looking for what is the probability that the proportion in one sample, so p hat is one sample, between 0.73 and 0.87. So I draw my normal curve,